Alright. Biorock by Corey Burns and Isaac Moore. What is electrolysis? Electrolysis is chemical decomposition produced by passing an electric current through a solution of electrolytes so that the electrolytes ions move toward the negative and positive electrodes and react with them. A basic example of this would be two chlorine ions going to in the product two chlorine atoms plus two electrons. When the chlorine ions in the electrolysis cell reach the anode, the extra electrons are taken away back into the power supply and the electrons are separated out. To dissect this picture a little bit, the way it works is essentially wires can connect metal rods that are suspended in a solution. The solution is composed of zinc sulfate and copper sulfate. The anode can be represented by zinc sulfate and the cathode by copper sulfate. Electrons flow from the anode to the cathode because the metal ions are actually consumed and the metal slowly wears away. The opposite happens at the cathode ion, where metal ions are gaining electrons and precipitate onto the cathode as pure metal, which will cause it to gradually grow larger. The salt bridge is connected, which allows the electrons to flow from the anode to the cathode. This example is essentially the role voltaic cells play in the production of a battery. What is Biorock? Biorock is a trade name, also known as cement, that refers to the substance formed by electroaccumulation of minerals dissolved in seawater. It works by passing a small electric current through electrodes in the water. It contains minerals like calcium, sulfur, potassium, and salt. Biorock is a large steel structure that can be in any form. It's successful because they require a very low voltage current, which will then create an electric field around the artificial reef. This helps corals grow faster and become healthier. What is Biorock technology? Biorock technology has been shown to increase coral growth in numerous coral reef restoration projects. It works by using electrically mediated calcium carbonate deposition on submerged metal surfaces. The minerals have been proven to be more efficient on metallic surfaces, meaning there's a better possibility of promotion of oyster growth. Oysters are artificially produced by Biorock technology. What mineral is being produced? Calcium carbonate is the mineral being produced in this experiment. The factors affecting the accretion rate was stability of metals, voltage of current, location of the wire being analyzed, water temperature, and pH. What is prevalent in the picture shown below is calcium carbonate. When it goes through water, eventually produces CO2 in the air.
What species is being tested? Oysters from experimental tanks and control tanks. For both years, it was discovered that the experimental tank oysters grew at a faster rate than the reefs in the control tank. In essence, the experimental tank oysters were larger in size towards the end of the study. The control group grew at an average of 2.36 millimeters in 3 months, and the experimental group grew at an average of 6.49 millimeters in 3 months. Mortality. The experimental tank showed a lower mortality than the control tanks. T-tests were conducted to analyze if the disparities in the data values were significant. In 2008, the mortality rate for the control tank oysters were more than double that of the experimental tank oysters. Advantages and disadvantages of Biorock. Some advantages: it gives marine organisms artificial place to grow in and around. It is self-repairing, increases removal of phytoplankton, minimal energy use, and has a restoration of oyster reefs. Some disadvantages are rock wool tubes inside Biorock are labeled as toxic. It will definitely be expensive to replace. Many failures with this production still needs minor improvements. Coral reefs remain susceptible to being damaged, and the cost about $1.60 to $2.80 per square meter for restoration, not including the height.